Again, as with many Ruby tools, the documentation, not so good. But my friend Eric Holscher, he of the Napping, has put together a pretty good 3-part series on his blog of getting started with Chef, which you should check out because it's pretty rad. So the other way that laziness applies to our role as deployment engineers is in sort of what I think of as a new set of lazy tools. I don't think that there's a mistake that sort of this rise of DevOps has been paralleled by a rise of sort of this NoSQL movement. And this idea of eventually consistent in particular is a really interesting idea because nearly all of the so-called web scale software has this idea of eventual consistency at its heart. That is, we can no longer expect that when we do an operation against our database that it's instantly available. We have to expect that we'll write to our database, and at some point later, that data is available for reading. That's a really big deal for writing software, right? Because if you're using a traditional relational database, you expect that any write you make is you can read back immediately. That seems like a basic assumption, but most of these new NoSQL-ish tools are breaking that assumption, which means that you have to take sort of data management logic and push that down into your application. You have to have code in your application to deal with the idiosyncrasies or the design decisions of the data storage layer that you're using. So you've got this mesh. You're intermeshing the needs of the back end of the server with the needs of the front end, right? You have developers saying, who are picking a particular data storage engine based on the application that they're building. And you have operations engineers telling developers, well, you can't write your application like that because of this requirement of the particular data storage engine that we've chosen. So these roles, these eventually consistent tools, these lazy tools, have the effect of bringing together development and operations and requiring them to be embodied in the same role. I should mention that queues are really huge. I think this NoSQL movement is a bit of a fad in that kind of it's even more of a vapor term than DevOps is, and we've had these we've had BDB for how long? So NoSQL, but I think queues are one of the big things to come out of this web scale movement. This idea that let's do some work, but let's do it later. This lets us as web developers break out of our request response cycle. Web developers, we're used to thinking in these very tiny time slices, right? Hundredths of a second that we have to process a request and get back. And by delaying and doing work later, we can break out of that and we can sort of take more advantage of the entire hardware stack that we're building up. The tool I really love is Celery. This is written in Python, although actually these days you can interact with Celery from other languages, which is going to tie into a point I want to make in a minute. And here's a little example code that shows you kind of just how easy it is. You just write this example here is some contrived example of like a Facebook-like thing where when you post a message, it needs to be delivered to all of your friends' inboxes. And if you try to do that in process during the post request, well, ask Twitter how well that works. You learn pretty quickly that some people have a lot more friends than other people, and it occurs to me on a totally random tangent that's like a classic engineer mistake. No one could have more than like 10 or 15 friends, right? Anyway, so this is sort of a contrived example where you might want to loop over all of a person's friends and post a message into their inbox. And you couldn't do that in process. It would make the request take too long. So you just take that function that you've already written, you wrap the Celery task decorator on it, and then later in your code you call task.delay, and Celery goes and does it later. It's so liberating to be able to say, you know what, I need to do this work, but I can tell the user that it's done and just kind of do it a little bit later. That's like classic laziness, right? A user says, hey, send this message to my friends, and yeah, I'm right, I'm get on it real soon now. classic laziness. So check out Fabric, check out Chef, check out Celery. These are all tools that, if you're not using them, it should be because you've thought about it and decided that you don't need it or that there's something better for you. So to come back to this, we're all ops people now. What this means is that as developers, we don't get to be ignorant of performance anymore, right? It used to be that as a developer, we maybe say, hey, what's my database connection information? Here, username, password, there's the server and the port. Okay. And if queries start taking a long time, you'd call up your DBA or your sysop and say, hey, make my queries faster. We don't get to have that luxury anymore. We're actually hitting ceilings on physical hardware limitations that we can, on making those queries fast enough. And so these performance concerns, typically things that used to be an operations engineer's problem, are being pushed down onto us as developers. In other words, I think we already are doing DevOps. We're already thinking about this. People are already thinking about it. When I'm mentioning Celery and when I'm mentioning Chef, I see people nodding. People are already using these tools, probably thinking of themselves as web developers. So the second virtue, impatience. So people get to be lazy, Larry says, but computers don't. Right? We feel very impatient when we feel like the computer is being lazy. And impatience drives us to write programs that, if possible, anticipate our behavior, or at least, fake it as much as they can. So I think, for me, impatience was the virtue that really drove me to try to formally conceive of what DevOps means, of how to make myself a better DevOps engineer. So I want you to ask yourself, how long does it take for you to push out a new deploy of your website? Raise your hand if you can do it in 5 minutes. Who can do it in 60 seconds?
The human part of the machine part.
So the rest of the rest of you, done. Like, I should be able, I can hit a button and have a new version of my website up, right? The rest of you can't do it in 60 seconds or 30. Why do you tolerate waiting that long? I'm impatient. I want it now. If something's broken and I want to tell my boss, well, that'll be. When something crops up on your server, how long does it take you to diagnose and fix it? That's real impatience right there, right? Your server's down. How long is it going to take you to fix it? That's definite impatience. What if you have a brand new, set of code to try out? How long does it take you to test your brand new deployment? Or do you just do what Dig does and then kick it out the door and hope it works? I'm betting a lot of people just kick it out the door, right? Yeah, I see some people nodding. How long does it take to provision a new server? If the answer involves, well, I gotta call someone in IT and place an order into Dell, that clock's ticking there. That's impatience right there. I've been working on problems where we physically couldn't get a new server in fast enough to solve the problem. That's bad. That's impatience. So I think this so-called cloud thing, solve some of these impatience problems. And like DevOps and like web scale and like all of these terms that I'm mentioning, there's a pretty healthy dose of BS in here. There's a lot of companies trying to sell you a bill of goods. I actually prefer the term utility computing to saying, cloud computing, or maybe infrastructure as a service, although that's kind of a mouthful. The reason I like it is because when you say utility computing, you think of this concept of computing as a utility, like electricity or water. It's something that you meter. You use some computing and then you turn it off, and you use some more and then you turn it off. And it's this idea of computing power as a commodity and as a sort of on-demand resource. And I think that's incredibly important. And once again, I don't think it's any mistake that this rise in cloud computing is happening at the same time as this rise in DevOps, right? I think these are all tied together. So this is what it takes for me to bring on a new web node on one of my stacks. I use an API command to boot a new machine. This example is using Rackspace Cloud, but it would be a different one-liner to do it on EC2.